Welcome back, Pre-Calc. We are continuing on with 3.2. And now that we've identified where the function hits the x-axis, where it's above the x-axis, where it's below, now we can start figuring out a little bit more the restricted values, domain, x-intercepts, y-intercepts, things like that, as well as the asymptotes and holes. So that's where we're headed with this. So the first premise, as a reminder, this is where x equals 0, which should shout out at you that that's going to give you the y-intercept. I'm well aware that some people think the y-intercept is always where the graph hits the y-axis, which is true. That's not wrong. But the formal definition is more along the lines of it's the y value when x equals 0. So what makes this value so easy is imagine for a second that you put in 0 for all these x's. Well, you get 0 minus 3 over 0 minus 0 minus 6. It's really straightforward, and then reduce, so 1/2. But the reason why we have that is we want you to identify that we just found the y-intercept. It's part of the process of how to get to the graph without a graphing calculator. So next one, there's a reason why I chose this value. Well, if you did f of -2, plugged in -2 in for all these values, I'm just going to show it up here. Just a reminder that -2 when you square is +4. This would be -2. This would be -2. Well, in the top, what you would get is 8 plus 10 minus 3. So 18 minus 3 will give me 15 divided by 4 plus 2 is 6. Minus 6 will give me 0. So I should really put an arrow right here because that's not a numerical value. That is undefined. F of -2 is undefined. But if you look back at your notes from the first section, we already talked about what this is an indicator of, because we have some constant where the constant's not 0 divided by 0 is your clue that this is a vertical asymptote at x equals -2. And we'll if you're still confused or a little hazy on these directions, we'll actually practice this and we'll get to it. So same thing with f of 3 now, but now this is going to be 3 squared, so it's 9, and then -5 times 3. I'll worry about that later. 9 minus 3 minus 6. So we get 18 minus 15 is 3, minus 3 is 0. And in the bottom you get 9 minus 3 is 6, minus 6 is 0. But again, I should change this to an arrow because that is not a numerical value. When you get 0 over 0, what that means is f of 3 is undefined, but 0 over 0 is your clue that that is a hole at that x value. We're going to do a little bit more with that here shortly. So in completely factored form, I'm going to assume that I would encourage you to pause the video and try to factor this yourself. That should be pretty straightforward for you. Otherwise, I'm just going to jump to the answer. If you've heard me in class, I'm a big fan of guessing and checking. For instance, there's only one way to get 2x squared. That's 2x times x. There's only one way to get 3, that's 1 times 3, but it's important where you put the 3. Well, I'm looking at that, and I'm thinking 2x times -3 is -6, and then plus 1 will give me -5, so that is the factored form. And then in the bottom, we have x plus 2, and x minus 3 will multiply to give me -6, and add to give me -1. So I factored it correctly. So what you should notice by this is there's several things. Well, the first thing that should pop out is that if I asked you to simplify this, well, how about this? Before simplifying it, maybe the first thing that pops out at you is x equals -2 and +3 when the denominator is set equal to 0. Well, what we learned in a previous unit is those are restricted values. What does that mean? Is that you cannot put -2 or +3 into the function, otherwise you'll get an undefined answer. So a restricted values I should say, are not part of the domain. We've talked about that before. If you still have questions on that, please ask in class. So what I was going to say is the first thing that might. So when you factor, so I started to say this wrong just like I did in the previous, is the canceling factor. Is your clue that it creates a hole at that value. And that's exactly what I was saying right there. These x minus 3's cancel, so there's a hole at x equals 3. And the last thing is, well, the non-canceling factor in the denominator is your clue that that's a vertical asymptote at x equals -2. Now, what about the non-canceling in the numerator? We actually talked about that before. Is non-canceling in the numerator, let me write that right here, is going to be the x-intercept. That's what section 1 was all about. So if you solve that, that would be at x equals -1/2. Perfect. Now I kind of defined the restricted value already, but let me just write down the process on finding the restricted value is setting the denominator equal to 0 and solve. But my definition, I'm going to stick with my definition. You probably won't find this in a math textbook, but it's where it's not part of the domain. So we call it a restricted value because we want to remove it from the domain, so we restrict ourselves from using it. I know I'm trying to get you to understand by using the same words, and that might not be beneficial for you. So if you still have questions on that, please ask me in class or ask a classmate. Maybe they can explain it in a slightly different phrase. So now they actually show you the picture to the right. Well, where are the restricted values that we found earlier? Well, when we set the denominator equal to 0, let's just show that work again, that x plus 2, x minus 3. So as a reminder, restricted values are setting the denominator equal to 0, and we can identify x equals -2, and, writing it over here for a reason, x equals 3. Well, what do you notice about the graph here? Well, at x equals -2, as was predicted, x equals -2 is a vertical asymptote. And what about this x equals 3? There's a hole at x equals 3. Now let's remind ourselves, so how did we find the domain of the function graph? Well, we set the denominator not equal to 0, and then we solved that. So x could not equal -2, and x could not equal 3. But we typically wrote it slightly different. We wrote -infinity to -2 union -2 to 3 union 3 to infinity. But we're doing the same thing. We're just adding a new word to it. We're going to be investigating these asymptotes, these holes. I'll actually tell you how to find the y value of that hole as well. All right. So what's the difference here? You set the denominator equal to 0 to find your restricted values. Well, what's the domain? It's the denominator not equal to 0. Well, how do you find the zeros? those are the non-canceling in the numerator, non-canceling factor or factors, because you can have more than one x-intercept in the numerator. And the very first problem we started with, how do you find the y-intercept? The y-intercept is the y value when x equals 0. I think I have enough time that I can power through these examples, finding all of those things. So start with factoring. By the way, don't be afraid to pause the video and go back, rewatch it. Again, I would probably just guess and check, because I need to somehow get -7. So I'm thinking about, okay, well, if I have 2 and 3, well, 3 times 3 make it -9 plus 2. It's just how my brain works. Might not work for you. Factoring the bottom is a little bit easier. X minus 3, x plus 1. So what are the restricted values? So I'm just going to do restricted right here. X equals -1 and +3. While I'm here, I might as well mention that these will cancel. So this is going to be my whole, whereas this is going to be my vertical asymptote. What is the 0? Well, that's the non-canceling in the numerator, so that would be x equals -2/3. And what's the y-intercept? Well, I don't like the simplified one, but you can use a simplified one, because if you plug in zeros into all of those, you would still get the right answer. But I like going to the first function. So I'm looking at plugging in 0 here, 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 and here, and I'm looking at the y-intercept would just be -6 divided by -3, which does reduce to 2. Could have done that with this function right here as well. Just not really a fan of that. Alright, so let's do the other one. G of x. You want to factor. Remember, the bottom is a difference of squares. So x plus 2, x minus 2. Please let me know if you forgot about difference of squares. And then we want factors of 10 that add to be 3. That would be 5 and 2. X plus 5, x minus 2. And then from there, it might be worthwhile to mention that these cancel. But you still want to say that x equals 2 is a restricted value, but that's a whole. X equals -2 is your vertical asymptote. And then x equals -5 is your 0, and then figuring out your y-intercept, plugging in zeros for all those x's, you're left with -10 over -4, which reduces to 5/2. I think you guys know me by now. I like my fractions. Now that I'm looking back at the notes, where it says the location of the whole, I interpret the location to be the x and y value. So let me teach you that now. So we know the x value of the whole is this. So it's at 3 comma something. Well, what you do is you plug it in for x. You plug 3 in for x into the factored form. You don't want to go back to the original problem because you'll get 0 over 0. Well, what is 0 over 0? I don't know. We've talked about that before. So what you want to do is plug it in here. Well, 3 times 3 is 9, plus 2 is 11, and 3 plus 1 is 4. So that's the location of your whole. Same thing with this one. Do not go back to g of x all the way up here, because you'll just get 0 over 0. That will not be correct. We know the x value is 2. You go right here and plug into the factored form. So we're looking at 2 plus 5 is 7, and 2 plus 2 is 4. And I've run out of time, so I'm going to stop my explanation here. If you feel like it, you can go to a graphing calculator and look for that whole, and you'll be able to find it.